Hi all, my name is Vincent and I'll be your host for the next 4 talks. And now the talk is titled Replacing Proprietary SAS with Open Source, Building a Marketing Analytics Web App with Python. And this talk represents a case study of replacing a proprietary marketing analytics platform with a dashboard and web app, using Python data ecosystem by Leo Anthias. Leo is the co-founder and CEO of DataPaint, an open source framework for creating data apps using Python and Jupyter. Please welcome him.
Thank you for the introduction. My name is Leo. I'm the CEO and co-founder of DataPaint. And in this talk, I'm going to show you how we can use DataPaint alongside other open source libraries to replace external SaaS platforms. So in this case, a marketing analytics platform. First, a little bit about DataPaint. So DataPaint is an open source SDK for building internal data products using Python. I'm going to show you a really quick example of the sort of things people build just before we continue. So that you can bear with me here. This tab. But what you can use DataPaint to do is create reports, dashboards, and interactive apps programmatically from inside of Python. So this is a report that someone created to do some kind of machine learning analysis. And you can see that I've got a couple of pages here. And inside of this are a bunch of DataPaint components, such as tabs, alongside visualizations from Python and data sets. So this is a totally standalone report. It actually doesn't even require a server to run. You can export it as a HTML file, email it to someone, send it on Slack. But at the same time, DataPaint also allows you to create full data products. So that ranges from automated dashboards, again, 100% using Python, all the way to web apps that also run back-end Python code. So I'm going to combine all of those different things to see if we can replace a proprietary software as a service product. So just go back here. You can check us out here. Give us a star, look at the gallery, etc. All the usual stuff. So hopefully this isn't a controversial statement at this conference, but we believe Python is the best way to analyze data. And I think it should be obvious from looking at all the other talks that you're seeing today. I think that the way to think about this is that the rate of change that you get in open source and that you get in Python is just so radically different to when you're using an off-the-shelf proprietary tool. Python has probably the richest ecosystem for analyzing data in the world, and we are obviously big fans of using it from everything from machine learning, really sophisticated stuff, but also simple analytics. The problem is that most of these things are inaccessible to 99% of people, right? Most people cannot run Python. If you take a Jupyter notebook or a Python script and you send it to someone who is not technical, they're not going to be able to make use of it. Stakeholders don't necessarily want to see all of your code, where you're like dropping a nan or cleaning up some data. They're more focused on the end result. A lot of analysts and people in traditional analytics teams know SQL and use a BI tool like Tableau or Looker and don't like Python. And I think it's fair to say that packaging and running Python is oftentimes a challenge. I don't think you want to sit down with your head of marketing and help them create a virtual environment and debug installing iArrow and getting a bunch of constraint problems. So Python is not an easy thing actually to get in the hands of people who are not technical. So what do? Usually they will go and buy a third-party product that is not created using the open source ecosystem. So I'm going to use the example of a marketing app that pulls data from Shopify, does some simple analyses, but there are actually boatloads of these vendors who create solutions for a specific use case, which realistically you could probably do in 50 to 100 lines of Python if you knew how to, but they can't do it because Python is not accessible to them. They can't take a Python script or a notebook and run it. And so what's the problem? What's wrong with this? I think that there are good sides. I think there are some benefits. A lot of these solutions, they're very accessible. They integrate heavily with the tools these people use, so they know how to get the data in the right shape. And they also integrate with where these people want data surfaced. So maybe they want it inside of Slack or Teams. Maybe they want it inside of something like Salesforce or Tableau. So there are definite benefits, and I think for companies who don't have anyone who can write code, these platforms can be a really, really good choice. I think the downside is that A, they're expensive, so you can end up paying, $200,000 to $300,000 a year for something that you could maybe do in 50 or 100 lines of Python. And they make it very difficult to integrate with data sets that are not inside of their constraints. They're generally extremely inflexible, both on the data side, but also on the analysis side. So say you wanted to integrate with another data source like your warehouse, or more common than not what we see is some like 2003 era Excel file that holds the entire business logic of the company that gets emailed around. They make it very difficult. They're very much everyone gets the same thing, right? They're not customized to the data, the integration, or the analysis that that company needs. And the other problem is that, as we're seeing through all the talks today, the rate of change in the Python ecosystem is really incredible. If you look at some of the talks you're going to see over the conference, it's impossible that these methods are going to be implemented in a third-party platform. Usually you'll get a small subset of them a couple of years later, but again, you don't get to ride the wave of all the cool things you can do using open source. So what about data apps? Obviously there are some great data app frameworks. One of them is data pane apps. There are obviously platforms like Streamlit or Voila. And I think these are fantastic for helping a data scientist share their analysis. If you want to go from a Python script to something that you want to throw up, maybe demo, create on a Zoom call, they're perfect for building that front end. But they don't actually provide an architecture for replacing a third-party platform. So they don't provide all of those moving pieces for creating a data product. Oftentimes they get used, like the report I showed you, as a little bit more like PowerPoint for data scientists. And that's really because a data product is a superset of a data app. The web framework is actually a relatively small part of what a lot of these platforms do. You've obviously got the web app, but you've probably got reporting as well that you need, scheduled reporting, background tasks, maybe dashboards. You have a data integration layer that needs to pull data from the various platforms that the app needs. So that could be an internal warehouse, but that could also be Shopify in this case. You need somewhere to store that, so some kind of OLAP layer. And then you need integration and automation into the different platforms that people are using to actually consume these insights. So data apps are fantastic at what they do, which is building a web server, but they don't give you an end-to-end data product. So what this usually means for companies is that you've got the data scientist writing the couple hundred lines of code, you've maybe got some data engineers helping with integration, but then they've got to get a huge number of other people involved to deliver an internal product. You've got a front-end engineer, probably writing React or Vue. You've got central IT, who then needs to procure like a data warehouse for you to integrate your data into. You've got back-end teams writing Django or Flask. And sooner rather than later, you're basically delivering like an entire software project, which is very expensive and time-consuming. So through this lens, it makes sense that people go to things that are not DIY, that are not created using Python and open source, and instead something off the shelf that they can spend a lot of money on, but that they don't have to get all of these people inside their company together to deliver. So with this in mind, we wanted to find out if there are a set of new technologies out there that can change this. So is there a way to reduce the effort to deliver a full data product which changes the dynamic of build versus buy? So it changes whether it makes sense for people to use Python and use open source inside their companies as opposed to going to an external vendor. And if there are, what is the best-in-class stack for this? So what is the right stack for creating a data product inside of your company? So the example we're going to use is a popular marketing analytics product, and this pulls data from Shopify, analyzes it using some common methods such as cohort analysis, retention analytics, and market basket analysis. And the question we're trying to answer is, can we replace this using Python? So I'm actually going to do the demo backwards by showing you the finished product, and then we'll break that down into how we actually built that. So here is the application. You can see my design skills are fantastic. Got a nice image there. And what this allows you to do is select a date range of data from Shopify. So this is order data as well as customer data, and 3 different data sets actually that's merging together. And what it creates here is an interactive application that I can then use. So I've got my orders, some high-level KPIs. Seems like this Shopify store is doing very well, over $1 billion of revenue. And I've also got an interactive map here. So this shows the top products distributed over a geography. I've created this using Folio. This also shows me some interesting summary statistics and some graphs for instance, the average order value, the most commonly ordered products by day of week, that kind of thing. And you can see that none of this is really rocket science. So doing this in Python using best-in-class libraries is not a research level project. Actually, what a lot of these platforms do can really be replaced in a minimal amount of Python. The next thing that I've got here is a market basket analysis. So this shows what popular products are ordered together. It sounds like round shipping insurance should probably be dropped from this to have a very useful chart, but shows you what products are frequently put in the basket at the same time. We have retention analysis. If you've used a traditional analytics product like Mixpanel, you've probably looked at a lot of these charts. It shows how many people after ordering will come back and order something again. And we've got a chart here showing which days that is most frequent on. And then finally, we've just got the entire data set. We've got about 1 million cells here that we can load into an interactive data table, and then say we wanted to run some SQL on this for an analyst, we can actually query that inside of our app. Great. So if we go back to the slides then, earlier we talked about what are the different parts of this app. So obviously the web app that I just showed you is one part of that, but what are the different moving pieces that we need to take into account? And for these moving pieces, what are the best-in-class libraries which we can use to get the job done as easily as possible? Now, one thing to note here is that we've opted for solutions that are simple for users to get started with, as opposed to the most powerful. So the goal is not to provide a huge enterprise architecture. The goal is to provide a simple way for a regular company to ship the data product. And I'm going to step through each of these parts of the life cycle. So step 1 is extracting, loading, and transforming the data in the first place. And I think the first question is, why do you need to do this? So could we not just have our app, when I click that run button, pull data down from something like Shopify, integrate it and transform it in process? And the answer is that it's too slow. So even with caching, this is very inefficient, and it can take minutes or hours to join the data from various REST APIs and get it in the right shape. So it has to happen out of band of the UI. This is something that, like many tasks in building one of these web products, should not happen when the user is using the interface. This should happen outside of that. So how do we get the data from Shopify? Now, luckily Python is great at integration, and you can whack up a Python script to pull data from many platforms that have an API, but you actually don't need to. There are libraries out there that make it really easy to take data from one place and shove it in a database. So we're using Singer and Meltano, which give you connectors to connect to, I think, hundreds of different platforms that you can connect into, from Salesforce to Shopify to Workday, and then you can load that into a database or a CSV or wherever you want to use as your data storage layer. So then the question is, where should we store this data? Should we go to central IT and say, I need a data warehouse? Should we get a database deployed? And our answer for this is actually no. You can skip the warehouse, and there are some fantastic libraries, which I'm going to focus here on DuckDB, that you can think of it as giving you a mini data warehouse that you can spin up in Python in a few milliseconds. So as opposed to having to go procure an entire data warehouse, you can get an OLAP layer for doing a lot of the analysis and transformation very, very quickly. And the obvious question for this is it going to be powerful enough? Am I going to be able to do everything I need to do in a in-memory database? And the answer for most of these apps is yes, is that you don't need to do a bunch of warehousing. The data is small enough to fit in memory, and on a single node with enough RAM on it and CPU, you can do a lot on using libraries like DuckDB as opposed to using a traditional warehouse. So I definitely check that out if you're going down that path. The next question is, how do you want to transform and join that data? So say you're pulling data from 3 different sources and you want to integrate it together into a data set for your app. What's the best way to do that? This is often a case of pick your poison. If you want to do it in SQL, you can do it in SQL using something on top of a database like Duck. We like to do it in Python. We traditionally have been using Polars and also Pandas v2, which is extremely fast at doing a lot of this transformation. I think it's almost 10 times faster for some of the things we're doing. So we're very Python first in the way that we're doing transformation. Finally, this can't be manual. So you don't want it that someone has to go and hit run to get the new data integrated. So you also need something to run on the schedule. You'll need a cron job or something similar, which takes the task that you created in Python and executes them maybe every day or every hour or whatever it is. And you can see here we're using the Shopify tap from Singer.io, and then we're loading that directly into DuckDB. So once we schedule that, that takes care of most of the extraction and loading of data for our app. The next layer is building the apps, reports, and dashboards on top of this data. So we're using DataPane for this, and DataPane allows you to programmatically create everything from a report to a scheduled live dashboard to a full-blown web app programmatically in Python. So in addition to actually the web app that I ran through here, we also created a report. And this report is special because, like the one I showed you earlier, you can download it, you can open it, and you can see this is just an HTML file on my local machine. I could send this on Slack, I could send this on Teams, I could even embed it into something like Tableau if I wanted. So it's a way to create things that are almost like the equivalent of a PDF, but still with some of that interactive nature, and you don't have to create a PDF, which is always a huge pain. Now, for the core analysis, I think I ran through most of the libraries that we're using. We're using really quite off-the-shelf stuff, so pandas, polars, PyArrow for some of the data storage. For this use case, there are also really great domain-specific libraries that I'd encourage you to look at as well. So Shopify in particular has open sourced some great Python libraries for doing things like LTV analysis or survival analysis. Some of them are using more classic statistical methods as opposed to heavy machine learning, so I'm not sure if they're state of the art, but we get really good results with them as well. On the visualization side, you can use whatever visualization library you want in Python. We're big users of Altair, which is Vega-like for Python. I think it fits really well for creating reusable visualizations that are lightweight and also interactive. But you can use anything from Matplotlib, Plotly, the choice is yours. Now, one challenge here is that similar to the data integration side, a lot of this can't happen in the UI. So you don't want it, so when someone goes to your app, it's necessarily doing all of the processing that has to happen before they can look at it. And DataPaint is a little different from other frameworks, and you can actually pre-render a lot of the views. So if I go to that app there and I'm clicking on a different tab, that's not actually going back to the server. That's all pre-rendered in the front end. And this can happen, again, out of band of someone using your product. You can have a scheduled task that does, obviously, the LTV, generates the plots, whatever you want to do. Now, the next part of this is automation and surfacing. So you can build a fantastic data product that does everything that people want, and no one will use it because it doesn't integrate into the platforms where they probably live. So an important part we've found of successfully building an internal data product is integrating very deeply with where people already are. In our experience, that traditionally looks like Slack or Teams. So maybe you can have some kind of triggered task that, for instance, when a certain metric changes, it sends a report to someone through Slack or through Teams. The other thing we found, surprisingly, is that embedding inside of Tableau works quite well. So Tableau is quite extensible, and you can create reports and apps and dashboards in Python, and then we have an extension so you can embed that into a dashboard that hopefully someone's already looking at. So I wouldn't take it for granted that just building the data product is enough. It really has to fit into somebody's workflow to make an impact. Now, I'm going to quickly walk through the code for how we built this. I've just got this open in GitHub web editor. I started using just hit the full stop on the GitHub repo, dive into VS Code, which is fantastic. I didn't have to say that because I'm in a Microsoft building. So you can see here that we start on the analytics.py. I've got about 300 lines of code, and this is just using basically pandas and Altair to do the visualizations. None of it is rocket science. This is on a GitHub repo, so you can have a look at it. But again, it's pretty simple stuff on the actual Python side. The second file to look at now is our app itself. So what these functions do is they create DataPaint components. You can think of DataPaint a little bit like something like React, where you can create components and you can actually compose them together. So these are the big numbers that you see in the app, and I can get these and return them from a function and then connect them together with some other components to create both my report and my app. So everything is happening on the actual app side in these two files here. These are mostly just called the other analytics file there. Finally, we've got a render function here that I'm calling, and just to note, you don't have to do this inside of regular Python, inside of using functions. I chose to do it because we reuse this app quite a lot. But if you're more comfortable just using Jupyter, we have pretty deep Jupyter integration as well. So you don't necessarily have to use the same method I've done here. But you can see the tabs that I've created. And then finally, I create a view using data pane, which is basically what you saw on the front page. You can see I've got the image here, and then I've got a very simple form. It's not the most sophisticated app in the world. And then when that form is called, it just calls the render function that returns another component. So very basic. Data pane is functions all the way down in Python. And again, you could be doing this on your local machine, or you could be doing it in a hosted notebook, Databricks, notebook, whatever it is, wherever you're most comfortable analyzing data. So here are the libraries that we built this app using. So we've got DuckDB for the OLAP lab, we've got Seaborn for some of the plots, we've got Vegalite, Altair, and we've taken these open source libraries, put them together, and created this data app, which I think goes pretty far to replacing the external vendor that we based it upon. So we've built this app now, but is this realistic or is it still too complicated? So one of the things we found with a lot of our users is that setting up things like a cron job or creating a lot of the infrastructure around this, even setting up DuckDB, can be quite a challenge if you've never built a data product before. Is it realistic that people are going to do this, that an individual data scientist is going to do this, or is there still too much complexity here? And what we thought was missing is an open source single format for defining, running, and deploying data products. So can you take this basically data stack that we've chosen with all of these different components from the open source ecosystem and create a simple format that allows people to run this as a package basically inside their company. So we're launching data pane packages, which does basically that. So at a high level, it takes all of those moving pieces and gives you a single Python file that you can then define all of these bits in, all the way from your scheduled tasks to your notifications, integrations into email and Slack, the OLAP layer as well if you want to use Duck. But it provides a really easy format for defining this in one place. And I can actually show you inside of the app that I built what this looks like. So again, I've got a single package here, and that package has a Python file. It has, I define what databases I want to use, the scheduled tasks, the notifications, and the workflows. So about 50 lines of Python to do this, and then you get basically a data product you can run inside your company. And then on the tasks, these are just pretty simple. This is actually reading from CSV in this case, and loading it into DuckDB. And it's also creating a daily report. So a data report that gets sent on Slack or email to people who need it. So as well as allowing you to define this format, we also provide the ability to run it, test it, and deploy it. So you can take this package and you can use data pane to actually run it inside of your company as an alternative to going to a non-open source vendor. The TLDR on this is that you can ship an end-to-end data product usually in less than a day. Everything's defined in 100% Python, and will handle basically the whole app lifecycle on top of that. Now, I've used a marketing app here. Obviously, this is not constrained to marketing. We have lots of open source apps that you can check out. Everything from HR Analytics, which I've got here, which provides an open source version of a common HR Analytics product that you can check out, and this has some interactive functions inside of it as well. All the way to more standard reports that you can see the source code for. Just check it out on the data pane website, or we've got a booth as well that you can see it on. I'll show you some demos of anything that's most relevant. If you want to get started, data pane is open source, so you can just pip install data pane. We also have a GitHub code spaces on try.datapane.com, so you can go to that and just be thrown into Jupyter Notebook, where you can build an app in a couple of minutes. And you can check us out on GitHub. The packages stuff is still in beta, so if you want a demo, you want to talk about that, you can come see us at our booth for early access and more examples. Any questions about anything that I've demoed today? Hi.
Is there any support for user input into, the backend OLAP or any user authentication, or would this be something that you embed into like a Django app?
Yeah, it's a very good question. And to be honest, we're still trying to figure out where authors should live. So you can, because our web server is WSGI, you can just embed it in Flask or Django and have basically handle auth yourself. We're running some experiments right now, especially on the HR side, where auth is really, really important, and things like RBAC are needed, where we expose that as a plugin as well, so that inside of your app, you can decide, based on the role of the person viewing it, what access to what data they should get. So I think there are some interesting approaches there we've looked at as well, outside of Dark, using things like row-based security as well in the database to make sure people are getting the right data. But yeah, there are a couple different ways to roll auth, and a lot of our customers are very opinionated about how they want it done. So, yeah.
Thank you.
Any other questions? Hey.
Hey, I'd like to know about how you handle handling large data sets efficiently. So if I have to put, a display of data frame, and then I say several plots of that same data frame, is the final thing that's got to be downloaded into that web page going to be 4 different copies of that same data, one for the plots, and one for another plot, one for the other plot, one for the sort of actual thing?
Yeah, so if you have, it's a question if you have 4 different data sets, would we do some kind of optimization where you don't have to download all 4 of them?
No, it's more like I'm looking at the same big blob of data from 4 different views, and can I do that efficiently without downloading 4 copies?
Oh, I see what you mean. Yeah, you can. So we have, first thing we do offer is caching. So data pane under the hood is a hypermedia format, and then these assets that you're pulling down, so that example, that data set, is pulled from our content layer as an arrow file, but that would be cached if it was being brought down under some different front-end transformations. We do have a kind of combination now of either working with data in the front end, so for instance, the data table, which I showed you, I think it was in the other app here, this data right now is working in the front end. So if I run this query, that's actually executing everything in memory in my browser. So I wouldn't recommend using this for a huge data set. This is like a million cells, so it's okay. But for doing anything larger than that, we'd probably recommend pushing that down to the, something like DuckDB and running it on the database.
I'm not quite sure how, like if I've made say a Matplotlib or something plot, right? And then I added that in. How does that work under the cover? Because my data's inside that plot.
Oh, yeah, sorry, I think I misunderstood your question. So in that case, you only have the SVG from Matplotlib. Okay. So the underlying data set doesn't have to get transported to the front end. You can think of this more as a kind of rendering. So we take, say, the Matplotlib figure, interactive plot, a data frame, all of those things, they become assets inside of your app here. But you don't need all the underlying data in the front end that generated them.
Okay, so you would have to avoid using something like Plotly that takes all the data and bundles it into the plot?
I'd recommend pre-aggregating the data usually before you get it into the plots. So I know that Altair generally puts a limit, I think of 5,000 rows or something on the.
That's not going to work for my data set.
Right, yeah. So in that case, the constraint would really be how much can the user's browser and Plotly itself handle efficiently. So also, we don't provide a visualization library, so you can use whichever one you want. But we try and make it work more efficiently, but some of it's outside our control as well.
Okay.
Hey.
Any native authentication options like Azure Active Directory and Okta or SSO providers out of the box?
Not yet, but it's one of the main things we're working So we'd absolutely, kind of similar to the conversation we had earlier, I think SSO and RBAC is going to be a really important thing for us. We're working with some of, it's mainly on the HR side that we're working with these customers to do that. And we're trying to design what the right API would look like. But we'd love your input. If you want to come to the booth, we can chat about it.
Thanks.
Great. Any other questions? No? Fantastic. Well, thank you so much for letting me show you what we're doing at DataPane. We have a booth around the corner, as I mentioned, that you can come and check out if you want to see any demos, if you want to see any examples, case studies. We've got a boatload of different data products that we've created that you can try out as well. So yeah, come and say hi. And thanks so much.